What's up, fellow Apply Maths? In this video of the Java Fundamentals tutorial, we'll be going over maps. A map contains values on the principle of key-value pairs. Each key and value pair is known as an entry. The key and values are considered as objects. Maps contain only unique keys, but they can contain duplicate keys. For example, key 1 and key 2 can both contain the value of 5. Maps are useful when you have to search, update, or delete elements by using a key. There are two interfaces for implementing the map interface in Java. There's the map and sorted map, and then the three classes are the HashMap, LinkedHashMap, and TreeMap. The HashMap is the map class that you're most likely going to be working with. The map interface and classes can be imported from the java.util package. So here's a simple diagram of the map interfaces and families. So the ones that are in a light tan color are interfaces, and the ones that are in a pink color are the classes. So first, at the top of the hierarchy is the map interface, and the sorted map interface extends that map interface, and the TreeMap class implements the sorted map interface. And on the right, we have the HashMap, which implements the map interface, and the LinkedHashMap, which extends the HashMap class. HashMaps and LinkedHashMaps allow for one null key and multiple null values, but TreeMaps don't allow for any null keys or values. And unlike list or set objects, maps cannot be looped. This requires converting the maps into a set by using the key set or an entry set method. So in this case, while maps themselves cannot be looped, as long as you call the key set or entry set methods, those maps will be able to be looped because the elements will take on the properties of a set collection. There are many more methods besides what's shown here, but just a quick overview. The put method is used to insert entry into the map, so you can think of this as an add method for the collections. The remove method deletes entries from the specified key that you pass in. And then the key set method returns a set view containing all the keys. And this is the method that allows you to iterate over the elements in the map. The clear method is used to reset the map. So basically clear the contents of the map. And then the contains value checks if there's a value that exists within a map. Contains key does the same, but for key objects. And we also have other methods as well, such as the equals method, which compare the element, a specific element or object within the map. And then the get method, which passes in the key, returns the value of that specific element in the map. So going over some of the classes of the map interface, the HashMap class uses a hash table to implement the map interface. The HashMap class represents a generally superior version of the hash table class, and the hash table class was a class that was previously used in older versions of Java, but you no longer see this class in newer Java environments. The HashMap class is not synchronized, so it's not thread safe. The HashMap class has no order, and it only allows for one null key and multiple null values. The LinkedHashMap class extends the HashMap class and maintains a linked list of the elements in the map in the order that they were inserted. So you can think of this as the linked list version for HashMaps. When iterating through the linked hash map, the elements will be returned in the order in which they were inserted. You can also create a linked hash map that returns its elements in the order in which they were last accessed. So just like hash maps, linked hash maps are not synchronized, and they also only allow for one null key and multiple null values. The TreeMap class implements the map interface by using a tree structure. This provides an efficient means of storing key value pairs in sorted order, as well as allowing for very fast retrieval. Unlike hash maps, TreeMaps guarantee that its elements will be sorted in ascending key order. TreeMaps, unlike HashMaps and linked HashMaps, do not allow for any null keys, but they can have multiple null values. And similar to HashMaps and linked HashMaps, TreeMaps are not synchronized. Alright, so now that we have a solid overview of maps and how they work, let's go into the code and try them out. Alright, so here are the code, and what I'm going to do is create a HashMap object that will add in a list of popular cities in the world. So I'll be using an integer for the key and then a string for the value for the hash map. So I created a hash map called popular cities. So I also imported the hash map class and the map interface. Also notice that how I have an integer as a first parameter and the string as a second parameter. So the first parameter will represent the index for the cities that we add, and the string will represent the actual city. So what I'm going to do now is add in 5 cities around the world. Alright, so I added in 6 cities. I know I said I'd added 5, but I want to add in a city for every continent in the world, except for Antarctica, of course. So I've added in 6 cities, and what I'm going to do now is iterate over those cities. Remember, to iterate over those cities, we need to call the key set and entry set methods. So in this case, we'll be using the entry set method, as well as the get key and the get value methods. All right, so I created a for each loop that's going to iterate over the elements that we have in the map. So let's run this right now and see what happens. All right, so here we got our results. We have from 1 through 6, New York, London, Tokyo, Cairo, Lima, and Sydney. So that's a quick example of how to add and iterate through maps. If you want to get a specific element in the map, all you have to do is just call the specific key value. So let's say we want to get the city Lima. So we know that the key is the number 5. So all we have to do is just call that in the get method. And then when we output this, so we see right here, our result is Lima because we retrieved the number 5 key from this hash map that we have, the popular cities hash map that we have, and that number 5 key holds the value of Lima. That's a pretty quick overview of maps. Again, I only briefly touched on this, and there's a lot more. You can play around with it as well as the methods. Maps are very useful, so I recommend that you test out some more on your own. All right, here's the assignment for this topic. Number 1, what are the 2 terms that enable a map to perform the retrieval of an object? Number 2, do maps allow for storing duplicate keys? Number 3, name 3 classes that implement the map interface. Give a sentence for what makes each map class stand out from the other. Number 4, write a map object that takes in an integer as a key and a string as the value. The map will contain 5 elements, ranking your 5 favorite foods from 1 to 5. Number 5, use the code from number 4. Add another key that uses 5 as an integer key, without using single quotes, of course, and make the value of that key as another food that you like. What happens to the previous value that originally was paired with key 5? If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.